The giant AI models we hear about every day, like those that power chatbots or create images, are incredibly powerful. But they have a big problem. Teaching them a new, specific skill is extremely expensive and time-consuming. This process, called fine-tuning, requires a huge amount of computational power, making it a major challenge for many developers and companies. Here's why this is important. If we can make this fine-tuning process cheaper and more efficient, it unlocks the ability for more people to customize these powerful AIs for their own unique needs. Researchers behind a new paper decided to look closely at what actually happens inside an AI's brain during this learning phase. An AI model is made up of millions or billions of connections, similar to neurons in our brain. Each connection has a weight, which represents its strength or importance. The common assumption was that you'd need to adjust many of these connections to teach the model something new. But the researchers noticed a fascinating pattern. The biggest learning changes were consistently happening to the connections with the smallest, weakest weights. The strong, established connections didn't seem to change as much. Let's explore what they found. Based on this key insight, they developed a new training method called nano-ADAM. It works on a simple but radical principle. During fine-tuning, just ignore the big, strong weights and only update the small, weak ones. This approach is brilliant for a few reasons. First, it's easy to implement. You don't need to do complex calculations to figure out which parts of the AI to train. You just pick the smallest weights. This saves a ton of energy. Second, it helps prevent AI amnesia. The large weights are thought to hold the AI's core knowledge from its original training. By leaving them alone, the model doesn't forget its foundational skills while learning a new one. Finally, and most surprisingly, this focused method actually leads to better performance and allows the AI to learn faster and more effectively. So, what does this mean in practice? This breakthrough could make custom AI much more accessible. A small business could afford to fine-tune a powerful language model to be an expert customer service agent for their specific products. Hospitals could more easily adapt a general medical imaging AI to work with their unique equipment. This research shows that sometimes the biggest improvements come from paying attention to the smallest details. If you enjoyed this breakdown, don't forget to like, comment, and subscribe for more AI research made simple.